Our Earth, a cradle of life in the vast expanse of space, revolves around a magnificent star, the Sun. This glowing orb of gas, primarily composed of hydrogen and helium, is the very heart of our solar system. It has been shining for about 4.6 billion years, providing the energy that fuels the life cycles of countless organisms on our planet. The Sun's gravitational pull keeps the planets, including Earth, in their orbits, creating a delicate balance that has allowed life to flourish. Without the Sun, our world would be a frozen, lifeless rock drifting aimlessly through the cosmos. A celestial furnace, the Sun bathes our planet in light and heat, making life as we know it possible. Its surface, a roiling sea of plasma, is marked by intense magnetic activity that can produce spectacular solar flares and coronal mass ejections. These phenomena not only create stunning visuals but also have profound effects on space weather, which can impact satellite communications and power grids on Earth. The energy produced in the Sun's core through nuclear fusion travels outward, eventually reaching us as sunlight, the very essence of life on Earth. But the Sun, for all its grandeur, is just one of billions upon billions of stars that populate our galaxy, the Milky Way. Each of these stars has its own story, its own unique characteristics, and many of them host their own planetary systems. The Milky Way itself is a vast spiral galaxy, stretching over 100,000 light-years across, with a supermassive black hole at its center. Our Sun resides in one of the galaxy's spiral arms, a relatively quiet neighborhood compared to the bustling core. And within this cosmic tapestry there exists a class of stars known as F-type stars, hotter, larger, and more luminous than our own Sun. These stars, often referred to as yellow-white dwarfs, can be up to 1.4 times more massive than the Sun, and can shine with a brilliance that outshines our star by several magnitudes. F-type stars have shorter lifespans than the Sun, burning through their nuclear fuel more quickly, but they also have the potential to host habitable zones where life could potentially arise. Imagine venturing beyond the familiar warmth of our Sun, journeying towards one of these F-type stars. The journey would be an odyssey through the vastness of space, traversing light-years of emptiness punctuated by the occasional celestial body. As we approach the F-type star, we would witness its intense luminosity, a beacon in the dark void, guiding us towards new frontiers of exploration and discovery. The journey would be a testament to the sheer scale and power of the universe, a breathtaking descent into the heart of a celestial inferno. The closer we get, the more we would feel the star's immense heat and radiation, a reminder of the raw, untamed forces that govern the cosmos. This voyage would not only expand our understanding of the universe but also inspire a profound sense of wonder and awe at the beauty and complexity of the stars that light up our night sky. F-type stars are like the universe's high-power generators. They're bigger and hotter than our Sun, with surface temperatures sizzling at thousands of degrees. These stars gleam with a brilliant white light, tinged with a subtle yellow hue, a clear sign of their intense energy output. Unlike cooler, redder stars, F-type stars live fast and die young. Their immense size and temperature fuel rapid nuclear reactions in their core, causing them to burn through their fuel reserves at an accelerated rate. This furious energy production makes them incredibly luminous, shining brightly across interstellar distances. As you approach an F-type star in your spaceship, the first sign of its power is the intense light. Even from a vast distance, the star shines with an almost blinding brilliance. The temperature outside your ship begins to rise steadily, a testament to the immense heat radiating from this celestial giant. Radiation levels soar as you draw closer. Your ship's hull creaks and groans, its protective shielding strained to the limit by the relentless bombardment of high-energy particles. The star looms large in your view screen, a swirling sphere of white-hot plasma. The ship shudders violently as you enter the star's outer atmosphere, the corona. This region is a chaotic ballet of superheated plasma, charged particles whipped into a frenzy by the star's powerful magnetic field. Temperatures here reach millions of degrees, hot enough to vaporize even the most resilient materials. Your ship is tossed about like a leaf in a hurricane, buffeted by waves of superheated plasma. The view outside is a mesmerizing yet terrifying spectacle. Streamers of ionized gas dance and writhe, their movements dictated by the star's unseen magnetic forces. Section 5. The photosphere, an ocean of fire. You plunge deeper into the star, crossing the boundary into the photosphere, the layer where the star's visible light originates. This is the region that gives the star its dazzling glow, the light that travels across the cosmos to reach our eyes. If the corona was chaotic, the photosphere is an inferno. Here, the temperature soars to nearly 6,000 degrees Celsius, making it a seething cauldron of energy and light. Here, the plasma is denser, hotter, and even more turbulent. The photosphere is a dynamic, ever-changing environment where waves of plasma rise and fall, creating a mesmerizing yet terrifying dance of fire. Imagine an ocean, not of water, but of fire. That's the photosphere. It's a vast, fiery expanse that stretches as far as the eye can see, a true ocean of flames. Giant convection cells, thousands of kilometers across, churn the plasma, transporting heat from the star's core to its surface. These cells are like massive, boiling pots, constantly stirring the star's outer layers. The pressure is immense, enough to crush your ship like an empty soda can. The sheer force within the photosphere is a testament to the incredible power of the star, a force that shapes the very fabric of our universe. Solar flares and sunspots are common sights here, each one a reminder of the star's volatile nature. These phenomena can release more energy in a few minutes than all the power plants on Earth combined. As you observe the photosphere, you realize that this fiery ocean is not just a source of light and heat, but a dynamic living entity. It's a place where the forces of nature are at their most extreme, a true marvel of the cosmos. Section 6, denser, hotter, deeper. The descent continues, each passing moment marked by increasing density and heat. The light from the photosphere fades behind you, replaced by a dull reddish glow emanating from the superheated plasma surrounding your ship. The atoms themselves are being squeezed together, stripped of their electrons by the immense pressure. The ship groans in protest, its hull nearing its melting point. You are now deep within the star, a realm where the laws of physics as we know them begin to break down. Section 7. The core, a cosmic furnace. Finally, you reach the core, the heart of the F-type star. This is where the real action happens. The cosmic furnace where hydrogen atoms are fused into helium under unimaginable pressure and temperature, releasing the energy that powers the star. The core is a place of unimaginable violence, a nuclear maelstrom where matter is constantly being created and destroyed. Temperatures here reach tens of millions of degrees, and the density is staggering. A thimbleful of this material would weigh millions of tons on Earth. Section 8. The final transformation. Your ship, unable to withstand the extreme conditions, finally succumbs. The metal melts away, then vaporizes, its atoms joining the maelstrom of the core. You too are not immune to the forces at play. Your body disintegrates, your atoms breaking down into their constituent particles. But this is not the end. Your atoms, forged in the heart of a dying star billions of years ago, are now returned to the cosmic crucible. They will be recycled, incorporated into new stars, planets, and perhaps even life itself. Section 9. Reflections on a cosmic journey. Falling into an F-type star is a journey of unimaginable extremes. The intense heat and pressure at the core of such a star are beyond human comprehension. Temperatures soar to millions of degrees, and the forces at play are so powerful that they can fuse hydrogen into helium, releasing vast amounts of energy in the process. This energy is what makes stars shine so brightly, illuminating the cosmos and providing the light that we see from Earth. It's a stark reminder of the sheer power and scale of the universe and the forces at play in the hearts of stars. These celestial bodies are not just distant points of light, they are dynamic, ever-changing entities that have a profound impact on the fabric of space and time. The gravity of a star can bend light, warp space, and even influence the orbits of planets and other celestial objects in its vicinity. But it's also a journey of transformation, a reminder that we are all connected to the cosmos, our atoms forged in the fiery furnaces of stars. Every element in our bodies, from the carbon in our cells to the iron in our blood, was created in the heart of a star. When these stars reach the end of their life cycles, they explode in supernovae, scattering these elements across the universe. This cosmic dust eventually coalesces to form new stars, planets, and even life itself. As we gaze upon the stars in the night sky, we are looking at the distant echoes of these cosmic processes. The light from these stars has traveled for millions, sometimes billions of years to reach us. In a way, we are looking back in time, witnessing the history of the universe unfold before our eyes. Each star tells a story, a narrative of creation, evolution, and eventual demise. A reminder that we are all stardust, and to stardust, we shall return. This realization can be both humbling and inspiring. It reminds us of our place in the grand scheme of things, and the interconnectedness of all life. We are not separate from the universe, we are an integral part of it. Our existence is a testament to the incredible processes that have shaped the cosmos over billions of years. As we continue to explore and understand the universe, we gain a deeper appreciation for the beauty and complexity of the world around us.